Right guys, I think we're going to start at 7 o'clock. Welcome aboard, nice to see you all. Hello Alice, hello T, hello Electric Y, hello Vin, hello Emmanuel, hello Taya. Who else we got on here? B, hi. Hello Henry. Hello Josh. So I've already mentioned to a few people here a bit early what the plan is for this evening. I'm hoping to make this session relevant to everybody. So I've gone through what's been seen on all three exam boards, and I picked out some topics that are still unseen on all three. I've also got some questions for both foundation and higher. So we'll kick off with crossover questions, which are relevant for foundation and higher students, and then we'll move on to higher tier only towards the end. Okay, hopefully it's going to be useful for all of you. I've also got some predicted papers if you've not seen those, so after this session, or if you get bored halfway through, perhaps you can go and have a look at those. Very generous, B. Hopefully that comes to pass, but keep your cash. Right, let's crack on. It's pretty much 7 o'clock. So yeah, I'm going to run through these topics here: best by, error and bounds, Venn diagrams and percentages for foundation higher, and then I'm going to move on and look at transformations of graphs, circle theorems, simultaneous equations, and volumes of 3D shapes. Now, you know, a lot of the other topics are covered already in the predicted papers. These ones I haven't covered quite so much, and they're kind of on all three exam boards still to be seen. So I thought they were good things to run through this evening. So I'm going to kick off with best by questions. So best by questions, top tips for these, just to make sure that you get the same amount of both things. If you've got a best by question, you need to have identical amounts of the two things you're comparing, otherwise you're not going to score any marks on those sorts of questions. The other top tip is often multiplying up is a lot easier than dividing down. So yeah, and we'll see that with some of these questions, I'm sure. So this first question is actually taken from an OCR paper. I'm going to be picking questions from all three exam boards to look at, so you can see yourself the differences between them are not actually that great when it comes down to it. So this one says a supermarket sells washing liquid in two sizes. I've got like 1.8 litres for £4.21, and I've got a 750 millilitres one for £1.70. And we're asked which size is better value for money. Show how you decide. Okay, so we need to have the same amount for both, and it doesn't really matter how much of each you get as long as you got the same amount of each. So that's my cuckoo clock just going off, and I forgot my calculator, so I feel a little bit more prepped now. So we need to find the same amount of both. So we can either cancel down to a smaller number. We could go all the way down to 1 milliliter, or we can scale up to a number that they both go into. With the calculator, it doesn't really matter so much. I'm probably going to just work out how much is for a litre, I guess, for each, and then we can compare them directly. Okay, so yeah, we're going to move on to higher a little bit later on. So we're going to start with crossover and then move on to pure higher in a minute. But all of these questions are on the higher paper, so if you're higher, you're good. Right, so if I've got the first one, let's have a look at the large one here then. So if I wanted to work out how much a litre of this is going to cost, we know that for 1 litre 80, it's, sorry, 1.8 litres is £4.21. So to get a litre's worth, you just need to divide through by £1.8 or 1.8, don't we? So for 1 litre, it's going to be £4.21 divided by 1.8, and what's that going to be then? So I've got my Wizzo calculator on the screen today. I have to use an old-fashioned one. So 4.21 divided by 1.8, that comes out to be 2.34 or £2.34 for a litre. Okay, and then for the other one, I've got 750 millilitres. If I want to scale that up to a litre, so the small one, I've got 700 millilitres. To get that up to a litre, I could divide by 3 times by 4, I guess. So if I've got £1.70 and I divide it by 3 and times by 4, that should give me a litre as well, because if I take 750 divided by 3, I'm going to get 250, times by 4, I'm going to get 1,000, aren't I? So 1.7 divided by 3 times by 4, that comes out to be £2.27 to the nearest penny. Okay, so you can see here then that the large bottle offers the best value for money. Oh no, it's the worst value for money, it's more expensive. The small one offers the best value of money, the £2.27 then, doesn't it? So which one am I going to go for? I'm going to go for the small one, and I've shown my method, so that's enough method to get the marks for that then. Right, I'm just going to read through the comments. Any questions on that one? No, I think we could probably move on. Why did I do 4/3? Because I was trying to standardise on 1 litre. I was trying to get 1 litre for each, and this one was 750 millilitres, and I thought, well, if I divide it by 3, that will give me 250 millilitres, and if I then times it by 4, it's going to take me up to 1,000. Now, like I said before, it doesn't really matter how much you standardise on, as long as you got the same amount of both of these questions, then it's good. Okay, hopefully that answers the 4/3 question. The other thing I could have done, I could have divided it by 750 and times by 1,000. That would have worked just as well. It's just more numbers to type in. You just need the same amount of both per me. So yeah, as long as you've got the same amount of both, you could divide both. You could divide it by 750 and the other one by 1,800. You've just got a really tiny decimal to compare. Okay. Right, let's move on. I've got another question. This one is from EdExcel then. So you can see they're not massively different from each other from one board to the next. Yeah, I'm going to do one from each exam board for each of the questions that we're going to cover. So Food Mart and Jan Store sell boxes of the same type of breakfast cereal. Each shop has a different offer. So in Food Mart, 400 grams, 20% off the normal price of £5. And in Jan Store, 400 grams plus 30% extra for £5. Which box of cereal is the better value for money? You must show your work. Okay, so this one is a slightly more complicated question because we have to work out how much of each we've got to start with before we can then go and compare them. So let's take Food Mart to start with. So I've got 400 grams and 20% off the normal price of £5. So what's that then? I'm just trying to wonder what the best way to do this one would be. Okay, well, let's work out what it's going to be first, and then we can have a think about it. So for Food Mart, £400 grams, 20% off. So if I've got, I tend to do my percentages with a little triangle like this. If you watch my videos, you've probably seen this before. So final, original, multiplier. I'm trying to work out the final here. I know the original is £5. And the multiplier, I've got 20% off. So if you start with 100% and you deduct 20%, that's 80%, and 80% as a multiplier is 0.8. So then if I want to find the final, then I need to do the original times the multiplier in order to find it. So final equals original times multiplier, which is going to be 5 times 0.8, which is, I think it's going to be 4, isn't it? 5 times 0.8, it's £4. Okay, so then that's £4 for 400 grams, okay, from Food Mart. And then for Jan Store, what we've got here, 400 grams plus 30% extra for £5. So they're going to get 30% extra on the 400 grams. So how much is that then? So final again is original times multiplier. So my original is going to be the 400 grams. And my multiplier here, if I'm going to add on 30%, 100% plus 30% is 130%, or 1.3 as a multiplier. Okay, so this is going to be the amount I'm working out here, isn't it? So 400 times 1.3, I make that 520 grams for £5. Okay, so we got two amounts and we got two costs that go with them. So read the chat. Okay, let me have a quick look. This is a foundation question, yeah. So this is from a foundation paper. Right, so now we need to work out the same amount of both. So I've got 400 grams for one and 520 grams for the other, and I need to know how much 1 gram is worth then. Probably is the easiest thing to do there. So if I've got 400 grams is 4 pounds, then 1 gram is going to be 4 pounds divided by 400 then, isn't it? I think it's going to be 1p a gram then, isn't it? So for 1 grams worth, if I take 4 pounds and I divide it by 400, that's going to be 1 pence per gram then, isn't it, for that one. And the second one, I've got 520 grams of 5 pounds, so if I take 500 and I divide it by 520, I think it's going to be slightly less than a penny then, isn't it? So 500 divided by 520, that is 0.0096. So it's slightly less than a penny then, isn't it? So which one ends up cheaper is going to be Jan's store. Jan's store is going to be the cheaper one of the two. So Jan's store is cheaper. It's not actually a very easy question, that one is a little bit tricky. Right, so then moving on, let's have a look at the next question. So this one is AQA. So again, very similar in style, got some better pictures, better quality artwork on the AQA paper. A shop sells 2 brands of batteries. I've got brand A, they come in packs of 8 and they're at £3.60 each. And we've got brand B, they come in packs of 6 and they're priced at £2.94. One brand A battery powers a toy for 5 hours. One brand B battery powers the same toy for 5.5 hours. Which brand is better value? You must show your work in. Okay, so that's quite a complicated one as well. Quite a lot going on in this question. So we need to work out how many hours worth of battery power I'm going to get from each of these, and then maybe work out the cost per battery power hour. Okay, so let's see if we can do that. Let's take brand A to start with then. So I've got eight batteries and they cost £3.60. So the total hours worth of power I'm going to get out of those 8 batteries then, how much is that then? So total power I'm going to get out of them is the 8 batteries times the 5 hours that they each last. So that's going to give me 40 hours worth of joy from my toy. And then for the brand B battery, so the total power of those is going to be the 6 batteries that last 5.5 hours each. So how much is that then? So 6 times 5.5, it comes out to be 33 hours of battery life from that one. So, but they come at different costs. So brand A costs £3.60 for 40 hours, and brand B costs £2.94 for 33 hours. So again, we need to try and standardise and maybe work out the cost of what 1 hour is. Wolf Taco, I'm kind of going through 3 questions on each topic, one from each exam board. So I've done the OCR one for this particular topic, but we've got some more OCR stuff coming up. Roji Joseph, it's a mixture. We've got AQA, OCR and EdExcel going on tonight, and it's all topics that are unseen on all 3 exam boards. Okay, so we haven't really had any Best Buy yet on any of the 3 exam boards, that's why I'm covering it. Okay, okay, so let's work out how much it costs for 1 hour's worth of battery life then. So if I take for 1 hour, it's going to be the cost of the 8 batteries, which is £3.60, and I'm going to divide that by the 40 hours that the battery lasts for. So £3.60 divided by 40 for that one. So £3.60 divided by 40, that comes out to be 9 pence. So that's 9 pence per hour for that one. And then the other one, so they're going to do something similar. So for 1 hour, it's going to be the cost of the 6 batteries divided by the 33 hours that they last. So what's £2.94 divided by 33? That's slightly less again. That's like 0.089. So it's a little bit less than 9 pence. So that's 0.089 pence per hour then in that case. So here brand B then offers a slightly better rate then. Okay, so that's brand B. Marginally. Okay. Right, I'm just going to check the comments before we move forward. Let's have a quick read through. Yeah, I'm doing every exam board. So if you're OCR, AQA, EdExcel, you're welcome. We're going to do questions from all of them. And you'll see yourself as we go through, they're not that massively different. You know, there's a few stylistic differences here and there, but I will point them out as we go through if I see anything that isn't on one board and it's on another, but I don't think there is. Okay, and I think it's interesting to see how the similar questions are pitched from different exam boards, and also you get to see what other exam boards might come up with next time, because they do borrow ideas from each other. Okay, right, so we're going to move on. After we've looked at Best Buy, we're going to be looking at error bounds for the next set of questions, and again I'm going to do one question from each of the 3 exam boards so you can see how they differ or how similar they are actually. So just some tips for error bounds. I like to draw a number line every time I do one of these. They're a little bit fiddly and it's easy to get confused in an exam. You know, there's a lot going on in your exam, you know. So it's good to write things down. I just drew a number line. I think it's easy to visualize it that way. And the other thing is you often have to decide which is the upper bound or lower bound after a series of calculations, and sometimes that's obvious to see, sometimes it isn't. If it isn't obvious, just work out all 4 and then you can pick which one is going to give you the highest or the lowest one after that. So how many marks for these sorts of questions? This is a 4 marker. Okay, so quite a lot of marks for these. Just to say that OCR, it's out of 100 marks, whereas the other 2 are out of 80. So OCR questions tend to be worth more marks than an AQA or an EdExcel one. So a 3 marker on an EdExcel AQA paper might be 4 on a OCR paper, because their papers are out of 100. Okay, they have a similar amount of content, they just mark it out of more marks. Right, so then OCR paper question. Sunil makes 7.5 litres of soup, correct to the nearest 0.5 litres. He serves the soup in 300 millilitre portions, correct to the nearest 10 millilitres. 24 people order this soup. Does Sunil definitely have enough soup to serve the 24 people? Show how you decide. Okay. So again, I'm gonna draw a number line for each of these. So for the soup, I'm going to draw a little number line. So we're told that it is 7.5 litres to the nearest 0.5 litres. So if I was going to draw a number line and I wrote 7.5 on it, and I was drawing numbers every half a litre, then the next number above that would be 8.0 and the one below it would be 7.0. Okay, so if you imagine that scale, then it's easy to imagine, well, which number's around to 7.5 then? It's going to be halfway between those or closer, isn't it? So this kind of region of numbers are going to round to 7.5. Any less than that's going to round down to 7. Anything more than that's going to round up to 8. Okay, so I just think this is a good way just to quickly visualize and put your method down. And then your error bounds, then they're going to be halfway between those numbers on the scale. So halfway between 7 and 7.5, that's going to be 7.25 for the lower bound and 7.75 for the upper bound. Okay, and then for the other thing we've got on here, what else have we got? We've got soup. He serves soup in 300 milliliter portions, correct to the nearest 10 milliliters. So this is for the serving then. So the servings are 300 milliliters, correct to the nearest 10 milliliters. So if I had a scale that was going up in 10 milliliters, then the next number up on my scale would be 310, and the one before it would be 290, wouldn't it? And so then the numbers that round to 300 on that scale are going to be halfway between those or closer. Okay, so what are those numbers? Well, halfway between 290 and 300 is 295, and halfway between 300 and 310 is 305. Okay, so they're all our limits. I started at 7, Puneet. So we're one set of questions in. We're just looking at the second set at the moment. So then what do I need to do? I need to work out how many portions of soup then I guess I can make and see if it's enough to serve 24 people. Okay, so now we want to look at the worst case scenario, don't we, here? So we want to know if it's enough for 24 people. So the worst case scenario is if the amount of soup that I've got is at the lower end of the range of possible values of soup, okay, and the servings of soup are at the upper end. Okay, so if you've got less soup and the servings are bigger each, then that's going to give you less servings altogether, then, isn't it? Now, if you find it difficult, like I said, if you find it difficult to figure this out, then you can just do every single combination. You can do lowest with lowest, lowest with highest, highest with lowest, highest with highest, and that'll give you 4 different numbers, and then you can pick which one it is. No, it's not pre-recorded, Vin. I can read what you're writing today. Right, so then what we're going to do here then, we're going to divide 7.25, we're going to divide by 305. Just note the change of units there. I've got 7.25 litres, which is 7,250 millilitres. And if I divide that by the 305 millilitre servings, that's going to tell me the number of servings I'm going to get then. Okay, so I'm going to do 7250 divided by 305. 7250. 7250 divided by 305. Calculator malfunction. That comes to be 23.78. I'm just going to round that up to 23.8. Okay, which is not quite enough servings of soup, is it? So one person's going to get a very little amount of soup in his bowl. Okay, so is it enough for 24 people? No, not enough soup to definitely serve 24. Okay. Right, so no, Vin's not going to the naughty step. He's allowed to make comments. Yeah, well, they need to be in the same units. Islamic EdEx 191. So you could. I went from litres into millilitres. You could have converted the serving into litres. They have to match though, don't they? So when you divide them, otherwise they're not going to match up. So yeah, I converted the litres into millilitres, but you could have also converted the millilitre serving into litres. Now, as I was saying before, if you're not quite sure which way delivers the least possible value, you could have tried all the combinations. So you could have done 7,750 divided by 305, and 7,750 divided by 295, and 7,250 divided by 295. They'd all give you slightly different values, but you know, you can then pick the one that is the least then in that case, if you're not quite sure how to figure it out. Okay, moving on to EdExcel. So a train travels along a track in 110 minutes, correct to the nearest 5 minutes. Jake finds that the track is 270 kilometers long. He assumes that the track has been measured correct to the nearest 10 kilometers. Could the average speed of the train have been greater than 160 kilometers per hour? You must show how you get your answer. Jack's assumption is wrong. The track was measured correct to the nearest 5 kilometers. Explain how this could affect your decision. So we've got two parts to this. Let's look at the first part first. This is the bit with the error bounds. So I'm gonna do the same thing as before. I'm gonna draw a number line. Just find it's a nice way to visualize it. So the train travelled along the track in 110 minutes. So this is time then, isn't it? that's 110, and it's correct to the nearest 5 minutes. So if I had a scale that was going up in fives, the next number on my scale would be 115, and the one before it would be 105. So then the numbers that round to 110 are going to be halfway between those or closer. So what are those numbers? Halfway between 105 and 110, well, that's 107.5, and halfway between 110 and 115, that's going to be 112.5. Okay? Right, so yeah, so that's the first error bound there, but then we've got, what else we've got? Correct in this 5 minutes. Jake then finds out the track is 270 kilometers long. He assumes the track has been measured correct to the nearest 10 kilometers. Okay, so the track length, so it's the distance, I suppose. It's going to be a distance, speed, time problem, isn't it? So the distance then is 270 kilometers to the nearest 10. So on my scale, 10 above that would be 280 and 10 below that would be 260. So then the numbers that round to 270 are going to be halfway between those or closer. So that's going to be 265 and 275 there for my my error bound there. For distance, then it says, could the average speed of the train have been greater than 160? So we want to find what the maximum speed is. Now if you remember your speed, distance, time triangle, distance, speed, time, we're trying to work out speed from distance and time. So speed equals distance divided by time, isn't it? So speed equals distance over time, and we want to find the biggest possible value for that. Now if you've got a fraction, the biggest fraction is the biggest possible denominator divided by your smallest possible numerator. That's going to give you your bigger fraction, isn't it? The number on the bottom, the smaller it is, the bigger your fraction is. The number on the top, the bigger it is, the bigger it is. So if I want to work out the highest possible speed, I need the highest distance. So I'm going to use this distance here, the 275, and I'm going to divide it by the smallest possible time, and that should give me the biggest possible speed. Now again, if you struggle with kind of figuring that out in your head, then the alternative is just to work out all three types. Do I want to do that in 107.5 minutes? I don't think so. I think I might want to convert that into hours. So, because I want it in kilometers per hour. So 107.5 minutes. What's that in hours? I could just type 107.5 into my calculator and divide it by 60, I guess. 107.5 divided by 60. It's not very nice. I think I might just divide it by 107.5 and times it by 60. In that case, that will turn it from hours per minute into miles per minute, kilometers per minute into kilometers per hour. Okay, so otherwise it's going to be a horrible calculation I don't really want to write down. So that's 275 divided by 107.5 times by 60, and that comes out to be 153.5 kilometers per hour. Wolf Taco, I think paper 3 is going to be the answer to your dreams. It's going to be perfect. It's going to be all the topics you prepped for, and it's going to be a breeze. 120 is 6. Okay, so yeah, so let's just wrap this one up then. So could the average speed of the train be greater than 160? Well, I've worked out the maximum speed is 153.5, so I'm going to answer no, cannot exceed 160 kilometers per hour. Not possible. Then it says in the next part, Jack's assumption was wrong. The track was measured correct to the nearest 5 meters. Explain how this would affect your decision in part A. Well, if it was to the nearest 5 than the nearest 10, then this upper bound would have been smaller than it would otherwise have been. That would have been rather than 275, it would have been 272.5, so that would have got smaller. So that means that number there would have got smaller. So that means the speed would have got less. So how is it going to affect my decision? It's not going to affect it. That's just going to give me a slower speed than I had, and it's certainly not going to get any closer to 160. So I'm going to say no effect, as the new speed would be less than before. Okay, something along those lines. So it's not going to affect my decision because the speed of the train would actually be going slower than it was before, so it definitely wouldn't go over 160. Right, so let me have a quick flick through the comments before moving on. I hope you're enjoying this. Like I say, it's my first live stream. I'm a little bit nervous to do it, but it's going. I don't know how you find that going. I'm doing my best, learning, struggling with the technology here, but I think I'm doing all right. So AQA, this is the AQA's version of these questions. This sign shows when a lift is safe to use. Total mass of people must be 450 kilograms or less. Ben and some other people are in the lift. Their total mass is 525 kilograms. The nearest 5 kilograms. Ben gets out. He has a mass of 78 kilograms to the nearest kilogram. Is the lift now safe to use? You must show you're working. Okay, so obviously you don't want to overload the lift. You don't want it all crashing down. So the total mass of people must be 450 kilograms or less. Ben and some other people in the lift, their total mass is 525 kilograms. So this is their mass. And then to the nearest 5 kilograms, so 5 above that would be 530, 5 below that would be 520. So the numbers that round to 525 then are going to be halfway in between or nearer. Okay, so you've seen for all 3 exam boards, I'm just doing exactly the same thing. They're not really that different from each other. 525.5 and 527.5 are my 2 limits for the mass of everybody. And then we've got Ben. His mass is, 78 kilograms, and he's to the nearest kilogram. So 1 kilogram above is 79, 1 below is 77. So then Ben's mass is going to be between those limits then. It's going to be 77.5 to 78.5. Okay? So then if he gets out, now with safety, you want the worst case scenario, don't you? So if you want to make sure something is safe, you need to consider the worst possible case. So the worst possible case is that everybody in the lift were at the upper end to start with. So they were kind of like at the heavy end of the weight range. So worst case scenario, the mass of all the people were at the top end of that error bound there. Okay? And that Ben is at the skinnier end of his. Okay, so when he gets out, the weight drops by the least possible amount. Okay, so then if we do that, and then if we take one away from the other, then so if I take 527.5, the upper bound of the mass, and I take away the lower bound of Ben, what does that give me? So 527.5 minus 77.5, that comes out to be 450 exactly. Okay, so the worst case scenario is there's exactly 450 kilograms worth of weight in the lift. Okay, now probably it's going to be slightly less than that because the mass of the group might have been slightly less, or the mass of Ben might have been slightly more. But it is 450, and the total mass of people must be 450 kilograms or less. So 450 is 450 or less, so that means the lift is now safe to use. So lift is now safe to use in the worst case scenario. Okay. So you've already done your exams in Scotland, have you? Awesome sauce, you lucky thing. You've already got it out the way. Right, so we're going through crossover topics today. If you've just joined in, I'm starting with crossover, foundation, high ones. I'm going to move on to high later. I'm covering questions from all 3 exam boards, OCR, EdExcel and AQA. And I'm going through one of each from each board, from each of a range of topics that have not come up yet on all 3 papers. Okay, so next one up, we're looking at Venn diagrams. Again, not seen really on all 3 papers, so you can expect to see it on any one of the 3 exam boards. This is OCR's effort at a Venn diagram question. So here's a Venn. We've got one number already on it. 80 people asked if they watch football or rugby. 29 said they watch football but not rugby. That one's actually already on the diagram, isn't it? So that one there, look. 29 said they watch football but not rugby. That's those guys who are already in there. 65 said they watch football. So 65, this one here, is everyone inside this whole circle here, look. Okay, so if there are 29 who are football only and 65 in that circle, then the ones in here then, in the middle, are going to be 65 minus 29, then, isn't it? So 65 minus 29, that is 36. So there are going to be 36 people sitting in the middle. Okay? And then it says 47 people said they watch rugby. So 47 people watch rugby. So again, that's everybody inside this pink circle here. They're the ones who watch rugby. But we've already accounted for 36. They're the people who watch football and rugby. So rugby only would be 47 minus 36, which is 11. So I'm going to have 11 people there who watch rugby only. So complete the Venn diagram. Not quite complete, is it? We just need, remember, we've got like a little mystery one on the outside here that we need to work out. So how are we going to do that? Well, we know that there are 80 people altogether. Okay, so those 3 numbers plus the mystery number should add up to 80. So I can work that one out then by taking 80 and subtracting the other 3 then. So the 29 plus the 36 plus the 11. Take those away from 80. So 29 and 11, that's 40, plus 36 is 76. That leaves me with 4, doesn't it? Okay, so I've got 4 people sitting outside the 2 circles down there. So those 4 numbers now should add up to 80. Okay? So I've completed the Venn diagram, so I've got my 3 marks for that. What percentage of the people asked do not watch football or rugby? Well, what percentage is it? So as a fraction, it's going to be those 4 people who are sitting on the outside there over the 80 people that got asked. And we need to write that as a percentage. So on your calculator, you're just going to do 40 divided by 80 times 100, and that's going to give you your percentage then, isn't it? So 4 divided by 80 times by 100, I make that 5%. Okay. I didn't think that was too bad, that one. That was all right. Let's have a look at the next one. This is a slightly different style. This one, this sort of Venn diagram, it's got these are what we call a summary Venn diagram. It's got like the number of elements that are in each of those sections. The EdExcel one, you have to actually write the elements in themselves. Okay, so we've got the universal set, and that's made up of the odd numbers less than 30. It's probably a good idea to list them. There's only 15 of them. So we've got 1, 3, 5, 7, 9, 11, 13, 15, I'm bored of doing this now, 17, 19, 21, 23, 25, 27, 29. Okay, they're all the numbers that are odd and less than 30. And we've got some of those in set A, and some of those in set B, and some of them that are neither. Okay, so I've got A in set A. Well, I think what I want to do is I want to work out the middle ones first. Is there any ones that go in the middle? It's usually good to start in the middle and work your way out with the Venn diagram. And you can see that I've got a 15 and a 15 in both of them. So I'm going to write a 15 in the middle section, I tend to draw a little dot next to my number when I've got actual elements, and I'm going to remember to cross out that I've used 15 because I want to work out how many numbers have to go on the outside it as well. And then, so the next, any others that are in both A and B? No, I think it's just 15. So then I've got 3, 9, 21 and 27 that are in A. So I've got 3, 9, 15, 21 and 27 in A. I'm just going to get rid of those from my list of numbers as well. So 3's gone, 9's gone, 21's gone, and 27's gone. And then I've got 5 and 25 in set B only. So 5 and 25. So I can get rid of those as well from my master list. So 5's gone and 25's gone. So that means all the other numbers are on the outside of that set. So I could just write those somewhere around the edge. So I've still got 1, I've got 7, I've got 11. I included far too many numbers in this question. It's really annoying. 17, 19, bad EdExcel, making me write all this, and 29. Okay, so it's probably a good idea just to double check that you've got the right number of numbers at the end. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I've got one too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Well, good job I checked because I've got one in the wrong place, haven't I? Oh, I wrote 15 twice here. Okay, so there we go. So let's see, it was worth checking that. Okay, so otherwise I got it wrong. Right, so then a number is chosen at random from the universal set. What's the probability that the number in the set is A union B? Now, if you're doing OCR, you don't do these. OCR don't bother with teaching set notation. They're not really big into notation in the OCR. That is equivalent to A or B. So what we're working out is the probability of A or B. Okay, so if it's in either an A or it's in B. Okay, so that is anything inside this circle plus anything in that circle there. Okay, so what is that then? I've got 1, 2, 3, 4, 5, 6, 7 elements altogether out of a total of 15 we said. Okay, so the probability that I pick one at random and it's in either A or B is going to be 7 over 15. Okay, and I'm not quite sure it printed out correctly. I'm going to go on and look at percentages. Right, let's have a look at the next one. Right, crossover percentages. So OCR question first. In July, the price of a holiday is £500. In August, the price increased by 25%, and in September, the price dropped by £500 again. Work out the percentage decrease from the August price to the September price. Okay, so you've got £500 holiday. It goes up by 25%, and then it drops down again, and it goes back to 25%. Okay, so what is the change there then? Now, you might be forgiven to thinking that it would have gone down by 25% again, but it doesn't quite work out that way. Okay, so let's have a think about what exactly would have happened then. If I've increased £500 by 25%, how much have I got now? Okay, so let's just do a quick calculation. Final original multiplier. So I'm starting with £500 and I'm going to increasing it by 25%. So if I've got 100% and I increase it by 25%, that is 125% then I've got. And that as a multiplier is going to be 1.25. Okay, so then the final then is going to be the original times the multiplier. It's going to be £500 times 1.25. So that means the price of the holiday is going to go up to 500 times 1.25. It's going to go up to £625. Okay. Now, when it goes back again to £500, that's not exactly going to be 25%, and I'll show you why. So again, if I do a second calculation, final original multiplier. This time I've got the final and the original, and I want the multiplier, don't I? So the final is going to go back to £500. The original was at £625, and then it dropped to £500. And what we want to do is find the multiplier here. Okay, so then from the triangle, cover up the thing we want to find. That tells me that it's going to be the final divided by the original. So my multiplier is final over original. It's going to be the £500 divided by the £625. What's that going to give me? That's 0.8. Okay, so that's 0.8, which is the same thing as 80%. So what has it gone down by? If it was at 100%, it's now 80. It's actually gone down by 20%. So that's a 20% deduction, or reduction I should say. Okay, so it went up, it was at £500, it went up 25%, it's now £625, but then to go back down to £500, that is a 20% deduction. Okay, so that is how much it's gone down by. So the percentage decrease from August to September is 20%. Okay, so a little bit doesn't kind of make as much sense as you might think it does. Next one, EdExcel. I've got Riddington and Greenwich. Riddington and Greenwich are two small villages. The population of Riddington has increased from 80 people to 120 people. The population of Greenwich has decreased from 200 people to 120 people. Show that Riddington has the greater percentage change in its population. You must show all your work in. Okay, so we're going to start off with Riddington. It's gone from 80 people to 120 people. So what's the percentage increase there? So final original multiplier, what have I got? So final, what's the final? It went from 80 people to 120 people. What's the original? That's the 80 people we started with, and we're trying to work out what the multiplier is. That's what we want. So the final is 120, the original is 80. What is the multiplier? Okay, so that's the one we're trying to find. This is how we're going to find it. So the multiplier is going to be final over original. It's going to be 120 over 80. What's that then? So 120 divided by 80. That's giving me 1.5 as a decimal. So what is that as a percentage? That's 150%. So that is a 50% increase. Remember, you always start with 100%. So if you're at 100 and you've now got 150, then you've gone up by 50%. Okay, so that's how much Riddington has gone up. Let's have a look at Greenwich. So again, going to do the same thing. Final original multiplier. What's F? What's O? What's M here? Okay, so here the final was 120. That's that one. The original was 200. This one's actually gone down, isn't it? And we want the multiplier again. Okay, so again, multiplier is final over original. So the final, what we said was 120, the original was 200. So we're going to do 120 over 200. What's that then? So 120 divided by 200. That's 0.6. And as a percentage, that's going to be 60%. So again, if you start with 100% and then you drop to 60%, that is a 40% decrease. Okay. Bye-bye, Siam. Good luck with the rest of your exams. So I'm going to move on. Let's have a look at the AQA questions. That was the EdExcel one. That wasn't too bad, that one. The AQA one, a voucher takes 15% off a bill. After using the voucher, the bill for a meal is £27.20. How much was the bill before the voucher? Okay, so let's have a quick think about this. So 15% off the bill. So this is going to be the multiplier, isn't it? So if we start off with 100% and we take 15% off, then that means we've got left with 100 minus 15, we've got 85% left. So the multiplier is going to be 85% or 0.85 in this question. So after using the voucher, the bill for the meal is £27.20. So is that the final or the original? The original is the amount that it starts with. How much was the bill before using the voucher? The final is the amount at the end of the meal, which was £27.20. So that's the final one there. So we're £27.20 is the final. The original is what we're trying to find. So covering up the original, it tells me that's the final divided by the multiplier. So original is final over multiplier. It's going to be £27.20 divided by 0.85. So this is a reverse percentage question, isn't it? Okay. So 27.2 divided by 0.85. That comes out to be 32. Okay, just a reality check before you move on. Does that make sense? Yeah, I mean, like the meal costs some money. You got a voucher off, then the price of the meal went down. So it kind of makes sense, doesn't it? £32 less 15% looks about £27.20. Does look about right. Just think it through those, because some people will just forget that they've been given the final, think it's the original, and multiply rather than divide, and end up with a number that's wrong. Okay, hopefully that isn't you. Okay. Shout out to Leicester. Who's from Leicester? Is that you, Pranam? I used to teach in Leicester a couple of years ago. Fine city. Right, so that is the end of the foundation questions that we're going to cover today. So we looked at a few. If you missed the beginning of the stream, then we looked through best by, error and bounds, Venn diagrams and percentages. So you could go back and look at those if you want to. I'm going to crack on and move on and look at some higher tier topics now. So if you're here for foundation, thanks for coming along. Good luck in your exam tomorrow. I've got some predicted papers. If you haven't seen those for foundation, go and have a look. I think it might be useful for this evening if you haven't looked at them already. Otherwise, take care and best of luck for tomorrow. I'm going to crack on and look at some higher tier topics. And the first topic I'm going to be looking at is transformations of graphs, which is always a firm favourite of students. Now I've got a little summary table here. This is kind of what you need to learn for transformations of graphs. You know, it's one of those topics that you have to actually learn some stuff, and if you don't know it, then you can't really access the questions. Okay. That might have been the case, Barb. I just had a bit of a brain freeze on that one. I'm not quite sure. I'll go back and have a look at it later. Right, so let's have a look at the types of transformations. There are 3 different types of transformations that you need to know for a higher tier. You've got translations, you've got reflections, which is similar to what you have to do in the actual topics of transformations. But we've also got stretch, which you don't have to do on normal transformations. Stretch is where you take something, you kind of stretch it up in 2 different directions away from the axes. Okay, but translations and reflections you should well know well enough from your work on normal transformations. Now, these transformations of graphs, they do things to the graphs themselves, and they also do things to the functions that underline the graphs. And some questions will look at just the graphs. Some questions will look at the functions, and some will look at both. Okay, I think when it looks at the actual functions, they're the hardest. The graph drawing ones aren't usually too bad. Okay, so let's have a look at EdExcel one to start with. I don't think this question's too hard. So this EdExcel question, the graph of y equals f of x. So some function in x is shown on both grids below. So I've got the first one here. On the grid, draw the graph of y equals 2 lots of f of x. So we've got our function f of x here, and we are doubling it. Okay, there's a little 2 in front of it. Okay, so if you have a look on our little table up here, f of x goes to a multiple of f of x, that's this one here, look, this one, kf of x. So it's a stretch scale factor k in the direction of y. Okay, so we're going to be taking the graph, we're going to be stretching it upwards, okay, by a scale factor of 2. So that means every point on the graph is going to end up twice as far away from the x-axis as it was to start with. So we take each of the points on the graph that you can easily read, and I'd say it's those 5 there, and you're going to move them so they're twice as far away from the axes. So this point here is going to go twice as far. It's 1 unit away, it's going to go 2 units away. This one is 1 unit away, it's going to go 2 units away. This one is 3 units away, it's going to go 6 units away. This one is 1 unit away, it's going to go 2 units away. This one is 1 away, it's going to go 2 units away. Okay, so then with a ruler, obviously, because they're drawn with a ruler, but although I'm cheating, you're then going to join those up with ruled lines, like I'm doing, honest. Okay, like that. So you can see your graph is kind of stretched upwards. It's the same shape, but it's kind of distorted slightly and got kind of longer. All right. So that's a stretch scale factor 2. This next one, I've got on the grid below, draw the graph of y equals f of x minus 3. So I'm taking 3 away from the value of x inside the bracket there. Okay. So if I come back and look at my table up here, which one is that then? It's going to be this one, isn't it? Where you take a number away from x. That's a translation of k units in the x direction. So if you take k away from x inside the bracket, you're shifting your graph k units to the right. Okay, that's what's happening there. So coming to this graph here, if I'm taking 3 away from the x value, it's going to have the effect of shifting the graph 3 units to the right. Okay, so you're going to take each one of your points that you can see clearly on the graph, and you're going to shift them 3 points to the right. So the first point is going to go 1, 2, 3, it's going to go there. Second point is going to go here. Third point, 1, 2, 3, it's going to go there. Fourth point is going to go 1, 2, 3, it's going to go there. And the last point is going to go there. Okay, and then just need to join those up. Again, do it with a ruler, like I am, honest. Okay, like that. So you can see it's just, so it's my cuckoo clock again, must be 8 o'clock. It's gone 3 units to the right there. Okay, so it's the same graph, it's just been shifted over a little bit. And so it's translated, it's a bit like translation, and when you're doing normal transformations, just pick up and move it 3 to the right. Okay, so that was the EdExcel version of the question. This is AQA, same thing, but with a squirrely graph here. A little bit harder this one, in that you have to kind of do a less easy graph to draw. We need to draw in the graph y equals minus f of x. So what transformation is that? So coming back to our table up here, y equals minus f of x. So minus sign in front of the function, it's this one here, look. It's a reflection in the x-axis. So it's one of the, like I say, it's one of those topics you just really need to remember this stuff. That's the only way around it. So you need to just try and commit it to memory. Okay. So minus f of x, a reflection in the x-axis. So I'm going to reflect this graph in the x-axis, and like it's a wibbly-wobbly graph, so it's not going to be the easiest to draw. But what I would do is just take some particular points and reflect those. So just some obvious points along the graph. So like that one up there is probably a good one to use, and that one, and that one, and that one, and that one, and that one. And we're going to reflect those points in the x-axis and work out where their image points are, and then we'll just join them up in a moment. So taking that first point up there, look, it's slightly to the left of -1, and it's going to be all the way down here, isn't it? So I'm going to put the image point down there in its kind of opposite place. This next point was at 1, so its image is going to be at -1. Points on the axes are going to remain, they're invariant, and then the next point along, what's that, like 3.5 little squares below, So its image point is going to be 3.5 little squares above. Then it's going to go through that point there again, and then we're going to end up low down there. So once we've got all our reference points in, then we just need to kind of draw that as best we can, matching the graph above. So it's going to come up like that. It's going to go through -1. It's going to go up through that point. It's going to peak at that little dot up there. It's going to go back down, and then all the way back down to that point down there. Okay, so as long as you've got like the reference points in the right place and it vaguely looks the right shape, you're going to get the marks for that sort of question. Okay. Right, so let's crack on. So that was all right. It was a little bit wibbly wobbly, but we managed to get through it. The OCR one, strangely, no picture. Describe the single transformation that maps the graph y equals x squared onto the graph of y equals x plus 3 all squared plus 5. Okay, so if you're having a look at what we've got here, y equals x squared, on OCR they don't use f of x, they don't use the notation, just stick with the equations. But if I've got y equals x squared and I go to y equals x plus 1, can you see I replaced the x in this function with x plus 3? So I've added 3 to the value of x inside the bracket there, and then I've added another 5 on the end. Okay, so this is like a composite transformation. It's doing two things. So if I come back up to our list of things there, we added 5 inside the function, and we add it outside the function as well. So when you add inside the function, we did that, didn't we? I can't remember if it was 2 or if it was 5, but we added something inside the function. That is a translation in the direction of x, and we also added to the outside of the function there. So we're going to translate it to the left, and I think it's actually, yeah, to the left, and we're all going to go up. So it's going to go along a bit and it's going to go up a bit. Okay, so let's have a look at how that would have happened then. So x plus 3 is actually 3 units to the left. The sign is always is in the opposite direction when you sub it inside the bracket. So that's going to be 3 units to the left. That one there, the yellow bit is going to shift it 3 units to the left, and the green bit is going to shift it 5 units up. Okay, so what single transformation will do that? It's a translation using vector. What's the vector going to be? For 3 units to the left and 5 units up, it's going to be -3, 5. Okay, so the translation of -3, 5 will take y equals x squared onto y equals x plus 3 all squared plus 5. Okay? Thank you for coming along, FSN Mega. Good to have your company. Any other questions in the chat? I am kind of looking through it every now and then. I've not quite got my live skills down pat just yet. I find it all a bit overwhelming, but I'll do my best, kind of hanging in there. Right, let's move on to the next topic. Going to look at circle theorems next. Again, not featured heavily on any of the boards so far. These are all the circle theorems that you need to know, and again, it's another one of those learning topics. You need to know all these if you're going to do quite well at the paper. You need to be able to spot these within a more complicated diagram. Okay, so let's see what we've got here. So this is the OCR question. A, B, C, and D are points on the circumference of a circle centre O. Angle BAD is 52 degrees. Work out angle X. Give a reason for your answer. Right, so we've got what we've got on here. So X is down here, look, and we've got an angle over here which is 52. So we've got this shape here. It looks a bit like an arrowhead, and we had one of those on our diagram, didn't we? It's this one up here, look. So got this arrowhead shape here appearing. So that one says the angle at the center is twice the angle at the circumference. So the angle at the center, x, is going to be twice as big as 52. So x is going to be 104. And the reason is angle at center is twice angle at circumference. Now, you do need to know these little phrases that I've written under here. Okay, I don't know if you want to take a screenshot of this, but yeah, if you need to remember the wording and the pictures, because some questions will ask you for the reason, and so you have to write the little wordy bit down underneath. Otherwise, you're not going to get all the marks, even if you worked out all the angles. Okay, and the next part of the question says work out angle Y, give a reason for your answer. Now you've got another shape that's in this diagram. So, you know, the trick about circle theorems is seeing the more simple shapes within the more complicated diagram. You've got here what we call a cyclic quadrilateral. You've got 4 corners sitting on the circumference of the circle, forming a cyclic quadrilateral. Okay, so if you come back up here to our list of rules, it's this one in the top right hand corner. We've got opposite angles in a cyclic quadrilateral add up to 180 degrees. So opposites here, so that one and that one add up to 180, and that one add up to 180. So that's quite a handy rule that we need to know. Okay, so then that means that my angle up here, the 52, and my angle Y have to add up to 180. And therefore y is going to be 180 minus 52. So 180 minus 52, what's that? That's 128. Okay, so y is 128. And what's the reason? It's a cyclic quadrilateral. Okay, so yeah, you don't have to write the whole thing down. There is a kind of minimum amount of words that you need to write down in order to get away with it. So cyclic quadrilateral is probably enough for that one. Okay. AQA, what have we got here then? So here is a cyclic quadrilateral. It tells you here. Work out and we know that x to y is in the ratio of 5 to 7, and we need to work out the size of angle W. So we've got a mixture of things going on here. We've got our cyclic quadrilateral, so we know that opposite angles add up to 180. Plus we've got this ratio over here that we're going to have to use in a minute, I guess. So let's start with x and y, because we know the ratio of those two things. So if I take x and y, these two angles here, these should add up to 180 degrees, shouldn't they? We know that x plus y is 180 degrees. We also know that they're in the ratio of 5 to 7, so this is actually a little bit like a dividing by a ratio question. So if I divide 180 in the ratio of 5 to 7, then the 5 part will be my x and the 7 part will be my y. Okay, so if I've got 5 shares and 7 shares, adding that together is going to give me 12 shares. Dividing 12 into 180, what's that, 15? 180 divided by 12 is 15. And then, taking our original ratio of 5 to 7 and then multiplying it up by a factor of 15, that's going to give me 75 and is that 105? Okay, so then x is going to be 75 then, and y is going to be 105. So once we know x, we can then look at this next angle over here. Then we know the actual size of that one then. If x is 75 and that angle up there is x plus 20, then that angle up there is going to have to be equal to 95. And then we can use the cyclic quadrilateral fact to find w then, can't we? So then w is going to be 180 minus the 95. That's going to give me 85, and that's my answer. Okay, so the AQA one, the circle theorem itself wasn't particularly difficult. It's a very simple one, but we've got some dividing by ratios and things like that chucked in for good measure. Right, okay, let's crack on. Right, so EdExcel question. We've got a few more circle theorems going on here. So it says point B, D, E and F lie on the circle. So we've got a cyclic quadrilateral going on there then, haven't we? Can you see that around there? So that's a cyclic quadrilateral. ABC is the tangent to the circle. So that's a tangent. Okay. Find the size of angle ABD. Where's ABD? We're actually trying to find this angle down here then, the angle between the tangent and that line there. Okay, you must give a reason for each stage of your working. Right, so we've got quite a few rules we can use here. So we've got like the cyclic quadrilateral that we just talked about earlier, where opposite sides add up to 180 degrees. Plus we've got this tangent. I think we're going to be using this rule here, the alternate segment theorem, where you've got an angle between the tangent and a chord, and that's equal to the angle in the alternate segment. I think that one's going to be quite useful. So what we're going to be doing is we're going to be finding this one probably by finding this one up here. Okay? No, not that one. No, not that one. Is it? This is the chord. Yeah, it's that angle there. Okay, so it's that one there what we need to find. So if you find that one, goes from here to here, look, then that's going to be the same as that one down there because of the alternate segment theorem. So how can we find that one? Well, if we find this one first, which is opposite our known angle in the cyclic quadrilateral, then we'll have 2 in the triangle, so we can find the third one, and then we can find the alternate angle over there. So I think that's the plan. So first off, we're going to find the angle DBF. So angle DBF, which is that angle up there, that is going to be equal to 180 minus 100, which is 80. So I need to give a reason for that, and that's because it's in a cyclic quadrilateral. Okay, so I know that's 80, and then I can work out the angle there at F. I can then work out, so that's BFD, and that's going to be 180 minus the 40 and the 80 that I just found. 40 plus 80 is 120, take away from 180 is 60 degrees, and that's because of angles in a triangle sum to 180. Okay, and then now that I know that that one is 60, well then that one is 60 as well because of the alternate segment theorem. So then angle ABD equals BFD, which is equal to 60, and that is because of the alternate segment theorem. Okay. Right, so I think that is all the circle theorems ones that we've gone through today. So we've seen all 3 of those. So moving swiftly on, solving simultaneous equations by substitutions. This tends to be where you've got like one linear equation and a not linear equation. In this case it's a quadratic, so I've got a quadratic and a linear. Now if you imagine you had a quadratic equation and a linear equation, you tend to get 2 points of intersection, and when you're solving equations simultaneously, that's what you're doing. You'll find, can I show the theorems quickly? Yes. Let me just get rid of those. If you want to take a screenshot of it, then that's all of them there, look. So you need to know the patterns and the wording, probably. Okay. Yeah, so when you're solving equations, you're finding these points of intersection between your 2 lines. So you're expecting to find 2 when you've got a quadratic and a linear because they cut in 2 places. That's not always the case. It could entirely miss, in which case you'll get no solutions, or it can just kind of, I missed there, but you can just kind of come up and touch the curve in one place, in which case you get what we call a repeated solution. Okay, so you either get 2, 1 or no solutions when you find these. You can't do the same method as you can with 2 linear equations, eliminate, where you just kind of take one away from the other. It doesn't kind of work. You can't cancel enough things out for it to work out. So instead we do something called substitution. If you have a look at our equation, I've got a curve which has equation y equals 4x squared plus 5x plus 3. So my y part is equal to all of this, okay? And then I've got a second equation which says y is equal to x plus 2. So again, my y part is equal to x plus 2. So if y is equal to that and y is equal to this, then those two things must be actually equal to each other, mustn't they? So if y equals y, 4x squared plus 5x plus 3 must be equal to x plus 2. Must be, because that's equal to y, that's equal to y. They're both equal to y, they're both equal to each other. So we can say then that 4x squared plus 5x plus 3 is equal to x plus 2. So, and this is what we mean by solving by substitution. We're substituting the y in the first equation with the value of y in the second equation. So yeah, that's what we've got. We just put those 2 bits together like that. Okay. Now to solve this, then what we need to do is we need to bring everything to one side and then hopefully factorize and find solutions that way. Okay, so taking x away from both sides, I'm going to get 4x squared plus 4x, and taking that 2 away as well, I'm going to get 4x squared plus 4x plus 1 is equal to 0. Okay, so now I'm going to have to see if I can factorize this. Hopefully I can. I hate it when you've got 4x at the beginning because there's different possibilities that you can get. It might be that you've got 4x and x like that, or it could be that you've got 2x and 2x. Okay, it could be either of those situations, not quite sure which. Luckily at the other end we've got a 1, so not many factor pairs of 1 are there? There's only 1 and 1. So really we need to think, well, is it going to be 4x plus 1, x plus 1? Is that the solution? Or is it going to be 2x plus 1, 2x plus 1? I think it's going to be the second one, because 2x times 1 and 2x times 1 is going to give you the 4x in the middle, whereas the other one is going to give you 5x. So it's not this one, it's this one here that it factorizes into. So I get 2x plus 1, 2x plus 1 is equal to 0. So that's giving me solutions. X is equal to 2x plus 1 is 0, so x is equal to a half, sorry, minus a half, and x is equal to minus a half over here as well. So this is an example where we've got a repeated solution. We've got 2 solutions and they're equal to the same thing. Can you use the quadratic formula for these? Yes, you can actually. It takes longer though. I mean, if you get used to factorising, you can factorise pretty quick, whereas the quadratic formula is a bit clunky. So I always try to factorise first, and if I can't factorise, then I'll fall back on the quadratic formula. But yeah, see if you can factorise first. So we factorised it, we found the solutions, we found we've got a repeated solution of x equals minus a half of both of them. I suppose the other thing we do is, if you've got any further mathematicians in the house, then we could also use the discriminant. You know, the discriminant is b squared minus 4ac. So if you work out b squared minus 4ac and show it's equal to 0, in this case it is b squared is 4 squared minus 4 times 1 times 4. You can show that that's equal to 0, and then that's sufficient to know there's only one solution as well. So if you've done further maths, then you might know what I'm talking about. If you haven't done further maths, you probably don't know what I'm talking about. Don't worry about it, just do it the other way. Okay? Yeah, so I found 2 solutions. So yeah, there's only one point of intersection because they're both in the same place. Okay? So that's the AQA question. Moving on to the EdExcel one. I will do an OCR one in a minute, Javi, so hang in there, I'll come on to it in a minute. But they're all pretty similar. You'd be able to use these skills on all 3 papers. And then EdExcel, the curve C is equation y equals x squared plus 3x minus 3. The line L has equation y minus 5x plus 4 is equal to 0. show algebraically that C and L have exactly 1 point in common. So it's pretty much the same question as before. It's made it slightly harder, and that the second equation for L is not in the form y is equal to. So the first thing we've got to do here is rearrange it to make y is equal to. So rearranging that equation L, I'm going to get y is equal to 5x minus 4, just taking the other two things to the other side. So again, I've got y is equal to this thing here, and I've got y is equal to this thing here. So if y is equal to that and y is equal to that, then those two things must be equal to each other. So I can say then that x squared plus 3x minus 3 is equal to 5x minus 4. Okay, and so again, next thing to do is to bring everything to one side. So what's that? No. Can you please find the hardest questions that most students get wrong? I did actually do a video on that, Ruben. If you look at my channel, there's one called like the top 10 hardest questions, and there's some really tricky ones in there, real stinkers. Go and have a look at those, you'll love it. He's only factorising to find solutions. Yeah, factorising I think is the easiest thing. How do you know when you just to make the y is equal? Well, I know I'm trying to sub one thing into the other, so I'm trying to get both equations equal to the same thing, so I can plug the two halves of the equation into each other, which is what I did here. So this equation y started out not with y the subject, so I just made it y the subject so I could plug it in the two halves of the thing together like that. Once I have got them looking like that, I can just bring everything over to one side again. So taking the 5x and the minus 4 over to the left, 3x minus 5x is minus 2x, and minus 3 plus 4 is plus 1 there. So it rearranges to x squared minus 2x plus 1 is equal to 0. Well, this one looks a whole lot easier to factorise. I've got no annoying 4x squared at the beginning, so it should be fairly easy then, shouldn't it? So plus at the end, minus in the middle. So I'm going to get x minus 1 inside my bracket, okay? So again, look, I've got a repeated solution. X is 1 and x is 1. So yeah, there we go. It's a show that there is exactly 1 point in common. So because I've got x is 1, it's a repeated solution. So only 1 point in common. Okay, so you don't need to go and find that point. It doesn't say what the point is. That's enough to prove that I've only got one solution, because so there can only be 1 point. Let's have a look at the OCR one. Slightly different equation here. Do you recognize this one? What's that? The equation of x squared plus y squared equals 34. What equation is that then? It's not quadratic this time. This is actually a circle equation, isn't it? X squared plus y squared equals r squared is the normal form of a circle. Now again, if you think about a circle and a straight line, then again you've got a similar thing going on there, isn't it? Either the line cuts a circle in two places, or it might just kind of touch a circle like a tangent, and then there's only 1 point of contact. Or it might entirely miss the circle and there'd be no solutions. Okay, so presumably there are two here, because there's two places on the answer line to write an x value and a y value twice. So I'm expecting it to go through twice, and there'd be two solutions in this case. Okay, now I can't just plug the two halves of the equation together. You're right, Super R, you did see a circle. So I can't just plug two halves together, because I've got a y squared here and not just a y, so I can't just match them up. But what I can do is I can replace the y inside the first function with x plus 7. So the substitution is a little bit more tricky. So x squared plus, rather than y squared, I'm gonna write that down instead. So x plus 2 all squared. So replaced the y part of the y squared there with the value of y in the second function. Okay, and then that's equal to 34. So then I'm going to multiply out those brackets. Now if you're not very good at quadratics, you can just do x plus 2 like that. That's going to give you x squared, 2x, 2x and 4. So that's x squared plus 4x plus 4 that you get there, isn't it? So I've got my x squared that I had before, plus my x squared plus 4x plus 4 I get from multiplying out those brackets, and I've got that 34 I had at the end. Okay, so now it's a matter of collecting all the like terms together. I've got a x squared term there and an x squared term there, so that gives me 2x squared. I've got a 4x all on its Todd there, so that's just plus 4x, and I've got a 4 there and a 34 on the other side. So if I take the 34 over, so subtract 34 from both sides, I'm going to end up with minus 30 on the end like that. Okay, so a slightly harder factorization to do here. Sky blue is this AQA. This particular one is OCR, but what I've been doing is I've been going through one of each type of question, sky blue. So I did an AQA one, then I did an EdExcel one, and OCR one. And if you'd been here, you'd notice that actually they're not that different from each other. And if there are differences, I've been pointing them out as I've gone along. Right, so then factorising this one, because I've got a 2x squared at the beginning, I'm going to have a 2x and an x inside my bracket. Factor pairs of 30, got lots of factor pairs of 30, far too many. Got to do a bit of thinking which pair is going to fit. I've got 1 and 30, 2 and 15, 3 and 10, any more? 5 and 6, so 4 possible pairs. And I need to think about which pair is going to deliver me that 4 in the middle. Bearing in mind that the number I put on the right, I'm going to multiply with the 2x, and the number I put on the left, I'm going to multiply with the x. Anyone know which pair it is? Which pair do you think I'm going to put in? Yeah, I'm doing volume next. That's the last topic I'm going to be looking at, and then I'm going to call it. So, which pair is going to give me my plus 4 in the middle? Now I think it's going to be the 3 and the 10, exactly Seb. It's going to be the 3 and the 10. But how do you get 4 from 3 and 10? But remember, whatever goes in the second bracket gets multiplied by that 2. So 2x times 3 is actually 6x. And if I put the 10 here, I'm going to get 10x. And then the 10x take away the 6x is going to give me the 4x in the middle. So it must be plus 10 minus 3 inside the bracket like that. Okay, so then what are the values of x that make that happen? So 2x plus 10 is 0, so 2x is minus 10, x is minus 5, so x is minus 5 is one solution, and x is 3 is the other solution. Okay, but this one we need to find the y values as well. So that's we've got two choices. We can either sub into the ridiculously hard one with squares in it, or we can sub into the nice one that doesn't have squares in it, so it's a bit of a no-brainer. So I'm going to plug it into y is equal to x plus 2 to find my corresponding values of y. So when I've got x is equal to minus 5, then y is going to be minus 5 plus 2, that's going to be minus 3, so minus 3 there. And when x is 3, then y is going to be 3 plus 2, that's going to be 5. So they're my values. I think someone's told me what it was a while back. I noticed someone typing that into the chat. Who was that then? Devi Anshu. Yeah, you got that right. Yeah, well done. Okay, so let's move on. So that's all the ones I've got on solving simultaneously. Hopefully that gave you an idea how to do those. This is the final set. I'm going to be looking at some shape of space. I'm going to look at some volumes here. Okay, first up I'm going to look at the OCR questions. I've got a diagram shows a cylinder and a cone. The cylinder has a radius of 2 centimeters, a height of 9. They're both on the diagram. The cone has a radius of r and a height of h. The ratio of r to h is 1 to 4. So we know that that is 1 for every 4 of those, but we don't know if exactly 1 and 4. The volume of the cone is equal to the volume of the cylinder. Work out the value of R. Okay, so that's going to be fun. Right, so let's work out the volume of the cylinder first. So the volume of the cylinder, what's that going to be equal to? So area of a volume of a cylinder. Volume of a cylinder. A cylinder is just a prism, isn't it? You've got the cross-sectional area, and you've got the distance between the front and the back face. That's how you work out the area of a prism. This particular question is an OCR one, and it's higher. We'll be looking at EdExcel and AQA straight afterwards. Okay, so but they're all the same. Won't worry about it too much. You'll see if you've been here for the whole stream, you'll notice there aren't actually that much difference between these questions. That's why I picked them. So the volume of the cylinder is the cross-sectional area times the distance between your faces. So the area of the cross-section is pi r squared for this one because it's a circle, and the distance between them is that 9, isn't it, along that length there. So pi r squared, that's going to be pi times 2 squared times 9. 2 squared is 4 times 9 is 36. That gives me 36 pi for the volume of the cylinder. I'm just going to leave it in terms of pi, hopefully. Okay. Will it always give you the formula for the cone, or might need to remember it? I think they tend to give it to you. They tend to give you the cone or the sphere. I don't know why they think they're too hard. It's just really, if you know the pyramid one, then you know the cone one. It's the same thing. It's just got a circular base. All right, so that's the cylinder. So we know the ratio of the radius to the height is 1 to 4. That means if the radius of the cylinder is r, then the height is going to be 4r, isn't it? It's going to be 4 times as big. So I'm not going to use h. I'm going to replace it with 4r because I know that the height is 4 lots of the radius. I'm just going to use 4r there. So then I don't have so many variables. And remember, I'm trying to find what r is. So if I just sub those two things in for r and h, then that will make my life easier. Okay, so then the volume of the cone, that is 1/3 times pi r squared times h, but I'm replacing h with 4r, if you remember. Okay, so what does that give me? That gives me 4/3 pi r cubed then, because I've joined the r with the r squared to give me r cubed, and I've joined the 4 with the third. 4 lots of a third is 4/3. So that means the volume of my cylinder is 4/3 pi r cubed. Now I'm told that these two things are equal to each other. So it should be that 4/3 pi r cubed is equal to 36 pi. So it's a good job I left it in terms of pi, because I can just then cancel those straight out and not have to worry about the horrible numbers. Okay, and then times them through by 3 and divide them by 4. So I can say that r cubed is 36 times 3 divided by 4, just flipping that fraction over, times them by 3 divided by 4. So 36 divided by 4 times by 3, that's 27, which is nice. That's a cube number, isn't it? Okay, so then if r cubed is 27, then r is going to be the cube root of 27. That's going to be 3 then, isn't it? So I know then my radius is 3. Is this foundation? No, this is a bit trickier than foundation, this one. You definitely need to know for foundation how to find the volume of the cylinder. So if you could do that first part there, then you're good for foundation. Cones is a little bit off-piste for foundation. Okay. Right, now this next one is an EdExcel question, and it is about a frustum. Now frustums are cones with the top cut off. They look a little bit like lampshades. Okay, so that's what a frustum is. So you've got a cone at the top that you slice off the top of your cone, and it leaves you with like that lampshade type thing. Now the question says a solid frustum is made by removing a small cone from a large cone. So you can see like the little dotted part at the top. That's like the ghost cone that got cut off the top. The slant height of the small cone is 6 centimeters, and the slant height of the large cone is 10 centimeters. The radius of the base of the large cone is 3 centimeters. Calculate the total surface area of the frustum. You must give your answer correct to 3 significant figures. So the total surface area of the frustum is going to be, how many faces has it got? How many faces does this frustum have? It's actually got 3 faces. It's got this circle part at the top. It's got a slightly different size circle at the bottom, so it can't just double one up. More work. And we've got like the curved surface around the edge, haven't we? You've got this kind of bit that goes around like that. Okay, so they've given us the formula for working out the curved part, but we've also got those 2 circles that we need to add on. Right. So quite a bit of work to do here. Now, the other thing that we can do with these questions from frustum is actually, like the little ghost cone that we cut off the top is mathematically similar to the one at the bottom. So, and because we know that that's 10 and that's 6, so the slant height of the big cone is 10 and the slant height of the little cone is 6, that means that they're in the ratio of 6 to 10, which is the same thing as 3 to 5. Okay, so they're in the ratio of 3 to 5, so we should then be able to work out the radius of the small cone, because it's going to be 3/5 of the area of the big one. Okay, because if that's 3 centimeters and then a ratio of 3 to 5, then if we take 3/5 of it, we're going to get the radius of the small circle up there then. So what is 3/5 of 3? So 3 times 3 divided by 5 is 1.8, okay, or as a fraction, is that 9 over 5? Might just leave it as 9 over 5 for now. So that's 9 over 5. Okay, so then what we're going to do here, so we need to work out the curved surface area of the small cone, take it away from the curved surface area of the big cone, or maybe we can just use similar shapes for that as well. I'm not quite sure what we're going to do there. And then we're going to add on the 2 surface areas of the circles. This is a horrible question. I don't know why I picked this one out. I don't want to do it now. So then, so the base of it is going to be, so the green circle is going to be pi r squared. It's going to be pi times 3 squared. It's going to be 9 pi. The smaller circle is going to also be pi r squared, which is pi times what we said, that's 9 over 5 squared. You can see why I didn't want to do it. So what's 9 over 5 squared? It's 3.25 pi apparently. And then we've got the curved surface of the big cone, which is pi RL. So pi RL for the big one is pi times the radius, which is 3, times the slant height of the big one, that's 30 pi. And then pi RL, the smaller ghost cone, that's also pi RL, which is pi times 6 times 9/5. So 6 times 9/5. Oh, I can't give me nice numbers. It's 10.8 pi. Okay, so then the total surface area. So as I say, let's just color code this. This is that was the small cone, the small circle, sorry. This was the big circle. This is the slant height of the big cone. And then this is the slant height of the ghost cone at the top, this bit up here. Okay, so then to work out the total surface area, it's going to be like the surface area of the slant surface area of the big cone minus the bit that got cut off, which was 10.8 pi, and then the small circle and the big circle. Okay, so we then need to add all that up, and that's going to be my total surface area. So I'm just going to do everything and then I'm going to multiply it by pi at the end. So I'm going to do 30 minus 10.8 plus 9 plus 3.25. That's 31.45 lots of pi, and then I can just times it by pi at the end. I make that. Can't read the decimal there. It's 98.8 to 3 significant figures. Didn't like that. I have to say, I don't like the EdExcel questions. The ones I'm doing, and they just give me, I just don't like them. They just seem to be a lot of work for no good reason. They're not testing your skills so much as just really long and boring. So anyway, that's 98.8 centimeters squared. Let's hope the AQA one is a little bit more fun. What time does this finish? This is the last question. Okay, so I'm out of material after this one. It's time you go to bed anyway, you guys, and you get some sleep. So the AQA one, sphere has radius 2x centimeters, a cone has radius 3x centimeters with a perpendicular height of h. The sphere and the cone have the same volume. Work out the radius of the cone to the perpendicular height of the cone. Give your answer in the form a to b, where a and b are integers. So this is a very algebraic one we've got here from AQA. I don't know if you notice, AQA seems to mix up things quite a bit more than the other two. A sphere is radius 2x. Well, the volume for a sphere is 4/3 pi r cubed. I'm probably going to call it actually CJ because I'm a bit tired now, but yeah, I'm going to do this one and I'm going to call it. I'll post a solution to the other one later if I have time to go and look at it. Okay. So anyway, the volume of the sphere is going to be 4/3 pi r cubed, and we're told that the radius is 2x. So that's going to be 4/3 of pi times 2x cubed. Now, when you're cubing something that's got more than one thing inside it, you're going to have to cube the 2 and cube the x, aren't you? So that's 4/3 pi times 8x cubed, because 2 cubed is 8 and x cubed is x cubed. Okay? So then I can combine the 8 with the 4. 8 times 4 is 20, it's 32. So it's 32 pi over 3x cubed for that one. Okay, so that's the sphere. And then we've got the cone. When we're going to do this, maybe budge this over a little bit so I've got space next to it here. So then the volume of my cone then is going to be, well, a cone is 1/3 of the area of the base, which is pi r squared, times the height. So that's 1/3 of pi. What's the radius here? It's 3x this time, so 3x squared, and the perpendicular height is just h. Okay, so then multiplying that out. So again, remember I'm going to have to square the 3 and square the x. So that's going to give me 1/3 of pi times 9x squared h. So this time I can cancel that 3 into the 9 and give me 3. So that simplifies down to 3 pi hx squared, like that. Okay? Phew. So what do I need to do now? I need to work out the radius of the cone to the perpendicular height of the cone. Why do I need to do that? That's just ridiculous. Right, so what we've got, the sphere and the cone have the same volume, so we can plug those into each other. So we can say that 32 pi over 3x cubed is equal to 3 pi hx squared. Ooh, that's not very nice. So then we get rid of the pi's. I might just multiply through that 3 and get 32x cubed equals 9x squared h. I'm going to divide both sides through by x squared, I think. So that will leave me with 32x equals 9h. I don't think 32 and 9 have any common factors though, annoyingly. So I think that's about as far as I'm going to get on that bit. Do they give the 4/3 pi r cubed? Yeah, they always give you the formula for a sphere when they get you to do it. Okay, so I've got 32x equals 9h. So work out the radius of the cone to the perpendicular height of the cone. So I'm going to do that then. So 3x to the radius is 3x. I suppose I could say that x is 9h over 32. If I rearrange it like that, then I know that the radius is 3x and the perpendicular height is h. So the radius of the cone is 3x to the perpendicular height of the cone, which is h. But I now know that x is 9h over 32. So I can replace that over there. So I can say that 3x, rather than writing 3x, I'm going to write 3 lots of 9h over 32 to h. Okay, so then just simplifying that, 3 times 9 is 27. So that gives me 27h over 32 to h. Okay, as a ratio. Almost done here. Then multiplying both sides by 32, that gives me 27h to 32h. Okay, and then we can just divide both sides by h to get rid of the h's, and then that will leave us with the ratio of 27 to 32 for the ratio of the radius of the cone to the height of the cone. That was a horrible question. I didn't like that at all. Not at 8:50 in the evening anyway. Okay, but we seem to have got to a solution as 27 to 32. Okay, so that's it. Okay, I think that's all I've got time to do. I'm running out of energy. I'm falling asleep a little bit here. So this week I've managed to get out about 10 videos for about 15 hours worth of content, which would have taken me about 40 hours worth of editing. So yeah, I think I'm done for the week. I'm going on holiday for a bit now, guys. I don't know about you. You've got a few more exams to do. Is it your last exam tomorrow, or you got more to do? Well, thank you guys for listening along. So thank you, Mr. Vic Football and Super R and Hasara, and who else has got to the end? Nick Gurr, well done for getting to the end. I'm going to go and crash and burn now because I'm so tired. Yeah, I probably won't go back and do that Venn diagram one, but I'll post up a solution if you're interested. Okay. Hopefully that was interesting. It's my first live, so I found it quite weird. I'm going to have less material next time because that was quite a slog. But yeah, kind of enjoyed it. I think I might do some more. You're welcome, T&K Adeyemi. You're most welcome. Thanks for coming on, Nieta. Really pleased that I had a few people come along. What did I say? What did I say about what? What did I say, Umar? I don't know. Would you rather gain knowledge or gain egos? I don't know. I'll ponder upon that one. Okay. All the best. Have a good one, guys. I'm going to stop streaming now. Ta-ra. Don't work too late.